Alrighty, so let's get started. Um, Professors, my name is Miles Irvin, and I did my concept map on my Surface Pro 3 because it was a lot easier to manage using the Pro Pen and being able to, draw this out and using the touchscreen and stuff. So I hope you can read all this. I'll be going through it and just kind of going around my chart. Okay, so I guess we can start with the major things, which are going to be that I've got inorganic chemistry and organic chemistry kind of separated out. There is a tie that brings the two together, of course, but for the most part, I've got the stuff that only relates to organic chemistry over there, and the inorganic stuff is kind of concentrated over here. So first things first. With inorganic chemistry, we start out with elements, atomic number, Dalton, atomic weight, and molecular weight. I group those concepts together because they're stuff that you would find, typically on the periodic table. Elements, obviously, are going to be tied over to where I put the organic chemistry stuff, which is, the basic building blocks of life, the carbon, oxygen, nitrogen, hydrogen, sulfur, all the rest of the elements. Those are located in organic chemistry, but I've got a tie here that brings them over to where I have my elements and the important stuff that's relevant to how the chemicals or how the elements bond and make chemicals and molecules and things like that. So just kind of moving over here. From the element, we have the atom, of course, which is the basic building block of all elements. Proton, neutron, electron. How the proton, neutron, obviously, is the nucleus of the atom, and how that relates to electron shells and valence electrons. Actually, I want to draw a box around this because these all kind of need to be together. Because that has to do with the internal structure of the atom itself and where those are located. So I'll group those concepts together. At the same time, I have another box over here that's relating to the neutron, which is like isotopes, the radioactive isotopes, half-life, isomers, all of those that have to do with variations of this atomic model, like variations in the neutron count, or differences in the makeup of the molecule itself, like an isomer, and I just felt like those fit neatly together. Okay, so then I've got bonds listed here under element and atom, which are the most important stuff. We have polar covalent bonds, non-polar covalent bonds, double covalent bonds. Let's see, triple covalent bonds. I just put parentheses here because I didn't want to write it out, but I'll just go on ahead. Polar covalent bond, triple covalent bond. Okay, just to be thorough anyway. So over here I drew hydrophobic interactions and electronegativity, which are components of water, obviously, and the polar covalent bond, so I kind of put those together. And then at the same time, on polar covalent bond, I actually probably could have combined these, but that's okay. I've got the properties of water, which include cohesion, adhesion, water itself, naturally, hydrogen bonding, and hydrogen bond network of water, which all kind of group together to describe how water adheres to itself through polar covalent bonds, how it creates structures, and how that all relates. Let's see. Okay, electron donor, electron acceptor are obviously they're having to do with bonds. Let's see. Oh, forgot about this one. I've got the mole, Avogadro's number, and molarity linked up here to molecular weight, which I had with element. Let's see. Okay, and then tying into bonds as well, just kind of going with the theme of chemicals, chemical reactions. I've got oxidation reduction reactions, and how those relate to acids, bases, how acid correlates to the hydrogen ion, naturally the base correlates to the hydronium ion, how when you mix the two together, um, you get a salt. pH, which naturally relates to the acidity or basicity of a substance, and then I kind of threw in cation anions over here just because it makes sense for having a positive or negatively charged ion, which are created or given up in an acid or base type solution. So I kind of felt like those all went together. And then I just kind of stuck down here the units of measurement, which didn't really, they don't really go with anything else. They're basic. Gram, meter, liter, milliliter, the stuff that we measure all matter with. Okay, so that kind of takes care of the organic chemistry section. Now, the organic chemistry is a lot more simplified just because I didn't really know how else to draw them out, and then I don't really know these as well as I thought I did. Of course, we got the main elements under organic chemistry. I already talked about that actually. Then down here we've got the functional groups: hydroxyl, carbonyl, ketone, aldehyde, carboxyl, carboxylic acid, amino, amine, alcohol, sulfhydryl, methyl, phosphate. I wasn't really sure how I needed to split those apart, but anyway. And then over here are the polymers and monomers: amino acids, proteins, nucleotides, nucleic acids, sugars, monosaccharides, polysaccharides, carbohydrates, lipids, phospholipids, unsaturated fats, saturated fats, glycerol, glycolipids, fatty acids, glycoprotein. And all of those, of course, are grouped under organic chemistry section, because those groups and those polymers, monomers, those are most often found in organic compositions, and so they just make sense to go there. So let me see. I think that covers about all the terms and just how I arrange them. Now that I'm doing the video, I realize that I probably could have rearranged a few things to make it a little more clear, but I've got it all there, and it makes sense for the most part. So anyway, hope this works.